This is a brief overview of the systems involved in the construction of the MR5 robot. You need to refer to the Systems in a Robot section of the workbook in order to complete this activity. The learning intentions are to understand the systems involved in a functioning robot. The success criteria is to identify each of the systems involved in the MR5 robot, to explain the purpose of each of the systems involved in the MR5 robot, and to begin to outline the relationship between the different systems. Your objectives will be to demonstrate an understanding of a robot in a written format and demonstrate an understanding of the MR5's key systems through a mind map. A robot can be considered as a set of working systems. So what is a robot? For our purposes, a robot is a device designed by humans to do work. By work, I mean physical activity. Usually, it involves mechanics and sensors. It usually is controlled by a computer program, and it involves a lot of systems. A system is a series of components that work together to achieve a purpose. The MR5 has a lot of what we call passive mechanical systems. The passive mechanical systems act like our skeleton. They provide the robot with shape and action, but these do not work by themselves. The key components are the 3D printed and laser cut parts, 22mm steel bearings, the same type of bearings you find in fidget spinners and skateboards, 30mm brass or steel offsets, and the key purposes are to provide shape and mechanical capability. It's also to hold electronic componentry and allow for further prototyping. The power system has a lot of key components in it. The main components that we need to consider are a 6.6 volt 4.5 amp hour lead acid battery, a number of power converters, an on-off switch, which is silly to consider, but it is actually part or a key component, a charging port. The key purposes of the power system are to power all electrical components in the system, to be low maintenance, to have a long use time. This one will last typically 2 hours under normal operations, and to be capable of powering expansions that we might decide to put onto the robot. The Motivator System or motion system has the following key components: 3D printed tracks, metal gear motors that in most cases are running at a 99:1 gear ratio, which work at 90 revolutions per minute, have a 15 kilogram per centimetre of torque. They also have this thing called an L298 difference motor driver. This enables the motor to be able to be controlled by a low voltage system that runs on 5 volts and step it up to the 6 volts required to run the power of the motors. The key purpose of the motivation system is to move the robot. The sensor system has the following key components at this stage: an ultrasonic distance sensor, which basically are the eyes on the front and work using echolocation, a photo gate, which is designed to set the speed of the motors, and the key purpose is to allow the robot to respond to objects and conditions in the real world. In future, the robot will also probably have a color sensor, a black and white sensor for sensing objects on the ground, and also some gyros and some temperature sensors. The processing system has a key component being a Raspberry Pi 3 computer. These Raspberry Pi computers have GPIO pins which control the circuitry that make the robot. It has a minimum 8 gigabytes of onboard memory, which means you can store quite a lot of information on it. And it has USB external storage, which means that when you save your work, you can save it to a USB external file rather than the onboard memory. This is safer because the robots will be re-imaged on a regular basis. It also has Wi-Fi and Bluetooth connectivity and will primarily use the Wi-Fi, although we may expand to use Bluetooth for remote control. The key purpose of this is to control both the motivation and sensor systems. We also have a software system. The software system is accessed through Raspberry Pi on an operating system called Jessie, and we access that over something called virtual network computing. We'll be using Scratch 2 to program for the first part, and we'll be moving to Python as a secondary. The key purpose of the software system is to allow humans to create instructions that allow the robot to carry out its task. The system relationships work as follows. We have a human who writes to the software system. The software system controls the processing system, so the software controls the Raspberry Pi. The processing system gets data to and from the sensor system. The processing system also tells the motivation system to move. The motivation system then interacts with the passive mechanical system to make the motion happen. This in turn also feeds back into the sensor system. Underlying all of this is a power system. The power system controls or gives power to the sensor system, to the processing system, and to the motivation system. In order to complete this activity, you need to go to the workbook and find the relevant pages. Once you've completed that activity, which involves filling out some information about what is a system and what is a robot, you then also need to do a mind map on the systems involved in the MR5. Once you've completed this, you need to scan it and Dropbox it to the appropriate Dropbox on the LMS. A student working beyond grade level will present an externally researched understanding of a robot, stretching from an historical perspective through to future predictions.